going to look at the first index law. Okay, if numbers are in an index form, which these two are, and they have the same base, they can be multiplied together using factor form. So this is what I mean by that. 2 to the power of 3, we can write that in factor form, which is 2 times 2 times 2. So 2 to the power of 3 we've listed as 2 times 2 times 2. And now we're going to times that by 2 to the power of 6. 1, 2, 3, 4, 5, 6. So from index form, I've written that in factor form. So I've colour-coded that there. 2 to the power of 3 I've written as 2 times 2 times 2, and I've multiplied it by 2 to the power of 6. You can see there now that I could write that solution in factor form, which is 2 to the power of 9, because there's 1, 2, 3, 4, 5, 6, 7, 8, 9 2's. So this is one way to do it. There is a simpler and faster way to multiply numbers or variables in index form with the same base, and this is index law 1. Must has the same base. If they've got the same base, so in this case the base is 2 in them both, then what we do is we write down 2 and we add these numbers here. 3 plus 6 gives us 2 to the power of 9. So that is simpler, faster way to solve this problem here. And that's index law 1. Doing it the long way, if you like, proves to you that this index law works. So when it's the same base and that's multiplied together, you can add the indices. So on the side, if we just do another one here, so if we had m to the power of 7 times m to the power of 3, rather than writing that out in factor form, have they got the same base? Yes, the base is m. Are they times together? Yes. So if they're both the same base and times together, we can simply add the indices. So that would give us m to the power of 10. Okay, let's look at worked example 6. Again, I'll put a little 1 there. So a reminder that there's a 1 there so you don't forget to add the 1. Let's do this using index law 1. Yes, they've all got the same base, so we write the base down 7, and then we add the index numbers together to give us 7 to the power of 8. That's why I often think it helps to put a 1 there so you don't forget to put the 1 there. Alright, let's look at the next one. Okay, with the next one, I'll do it the long way and then show you how the index law works for this. 5e to the power of 10 is 5 times by, we've got to do 10 e's. 3, 4, 5, 6, 7, 8, 9, 10. And I then times that by 2 e cubed, so 3 e's. What I then do, if I was doing it the long way, I would get my big numbers, I call them big numbers, and multiply them together. And then I get my e's and work out how many e's there are. So this is the long way, if you like, to do it. So multiply my big numbers together. 5 times 2 is 10, and then if I count how many pink e's there are, it's e to the power of 13. So the quicker way to do it, we'll do it over here, 5e to the 10 times by 2e to the power of 3. So what we do for this is we multiply our numbers that aren't attached to an index. So 5 times 2 is 10, and then with the e's we say n to the t plus 3 because we add the indices, which is 10e to the 13. Much quicker way than what we did over here. Alright, so let's do this one. You notice this one involves m and n's and then normal numbers. So I'll just draw using colour coding again. So here is my normal numbers. Here is my m's. And then a different colour, I've got my n's. So using index law 1, Look at the green information. 7 times 2 is 14. Look at the aqua information. M to the 3 times M to the 8. Index law 1 tells me I add the 3 and 8. Look at my n's. That's the yellow. I've got n to the 5. Index law 1 says 5 plus 4. So this would be 14, m to the 11, n to the 9. So basically, index law 1 says something like this. If the bases are the same, in this case both bases are A, and they are times together, so both bases are A and they are times together, we add the indices together. That is index law 1.